Welcome to EDU World Space.
Okay, problem 7.74. We have a small object with mass of 0.09 kilogram, and it moves along the positive x-axis. And we have that the only force acting on it is a conservative force with potential energy function negative ax squared plus bx cubed, where we have alpha and b defined here. And the object is released from rest at small x, and when it says small x, we can assume very close to 0 is what it means. And when the object is at 4 meters, what are the speed, acceleration of the object? Okay, so first off, I'm going to say conservative force means that we're going to have a conservation of energy between the point 0 and 0.4 here. So that means I can write potential energy at 0.0 plus the kinetic energy at 0.0 equals the potential energy at 4, x equals 4, plus the kinetic energy at x equals 4. Okay, so we can immediately find out what some of these things are. We have the potential energy function. We can just plug in 0. So use 0 equals something times x squared times something plus times x cubed. So that's 0 plus 0. So that's equal to 0. We're told that the energy is released from rest. So we can assume that the kinetic energy is equal to 0 at x equals 0. Okay, then so that becomes 0 plus 0 equals u4 plus k4. So we need to figure out what the speed is. So we need to figure out what u4 is. So u at x equals 4. Basically just plug in another 4 equals negative 2 times 4 squared plus b times, let's see, and then b is 0.3 times 4 cubed, and that comes out to be 12.8, negative 12.8 joules. Okay, so bring that all down here. We have 0 plus 0 equal to negative 12.8 joules plus K4. Okay, so bring over the 12.8, and we have that the 12.8 joules is equal to the kinetic energy object. So that's equal to 1/2 our mass and then times our velocity squared. Okay, so then this comes out to have velocity is equal to 16.87 meters per second at position 4. Okay, so that's A. B, we need to figure out the acceleration of the object. So we're given the potential energy function here, and I know there's a relationship between the force and the potential energy, and that's going to be force is equal to a negative d over dx, the potential energy. Okay, and I know how to relate that to that force to the acceleration. So that's is equal to mass times acceleration. So it's easy enough to figure out what this derivative is and divide by mass to find the acceleration. Okay, so the negative d over dx of the potential energy. So I'm going to bring down the 2, so that's negative a2x, reduce power from 2 to 1, and then plus b, bring down the 3, reduce this power to 2. Okay, and then that's going to be equal to 2ax minus 3bx squared. Okay, so then that force is equal to mass times acceleration. So we write that the acceleration at 0.4 is equal to the force at 0.4 divided by mass. Okay, so then we get 1 over the mass times 2a4 minus 3b4 squared. And that comes out to be 17.8 meters per second squared. Okay, so that's the acceleration. And C, what is the maximum value of x reached by the object during its motion? So if we were to plot this on a 2D graph, what the potential energy function looks like, it would look something like this. It would reach a max at 0, down and up at some point over here. So what we need to do is we need to find out what the maximum value of x is. And to do that, we simply just need to set the potential energy equal to 0 and find out what x solutions are possible. We know that x equals 0 should be 1. So let's see what we get. We have u of x equals 0, and that's equal to negative a x squared minus b x cubed. We can factor that out. We have x squared negative a plus bx. So we know that one solution of x is 0. So we can factor that out and divide by x squared. And we just get 0 is equal to negative a plus bx. And that gets a solution of a over b. So that's 2 divided by 0.3, and we get 6.66 to be a solution for where it reaches the maximum value of x, right there. And that's our solution.